In this video, I'm going to discuss some of the improvements to the PC-DMIS basic loader that have been added to revision 905. We received a basic file, and when it was translated, the log file showed quite a few statements that weren't being processed. Things that control the output format in detail, like dimension format and display precision, were normal. We didn't expect to support those, neither do we things associated with the probe. But there were these assignment statements, basic scripts, generic constructions, and best fit 2D alignments that were being missed. So support has been added for generic constructions, assignments, best fit 2D and best fit 3D alignments. We haven't done anything to do with the basic script because that would expect the system to be hooked into PC-DMIS. And we've added support for one more flavor of comment. In PC-DMIS, there are 4 flavors of comment that we run into. Some become operator instructions, text opper. Some go into the output file, text outfill. Some become program comments with a double $sign. The new one that we hadn't yet supported causes a prompt. So for instance, enter ambient temperature. It has a variable and that value gets shoved into the variable. In the PC-DMIS world, a number gets out of that input via this assignment mechanism. Assigned statements get translated into commented out DMIS assigned statements where the variable name equals assigned slash and whatever the expression was. The expression is not likely to be valid DMIS, so that's why they're commented out. I'll show how these can be handled editing the DMIS file. It's pretty hard for the loader to reverse engineer the intent that's going on. The other thing that's now handled are these generic constructions. The way they look in the basic file is there's an XYZ nominal, perhaps a diameter setup. These things can be points, lines, planes, circles. And after this feature's basically been defined nominally, it comes back and uses high-level variables and overrides some of the values that are in here. The important thing is what is the feature type? There's point, line, circle, plane. And by making this generic feature, tolerances can be attached to it. For instance, this one has this temperature tolerance. So if we follow the logic, C1 is the answer to enter ambient temperature. T1 is the number pulled out of C1. And this constructed generic, you can see that T1 is being shoved into the measured Z. So that's what they're trying to do. And there's a couple of other things that they do using those sort of techniques. The other thing I mentioned was these 2D and 3D best fit alignments. They become locate soft orient alignments, and the 2D ones will specify movement only in 2 directions, whereas the 3D will have 3D movement. The 2D one has 1 axis of rotation, whereas the 3D has 3 axes of rotation. At this point, I'm going to output the program to Wenzel OpenDMIS just to show you the sort of hand editing that would be necessary to get this file to function the way it did in PC-DMIS. So here's our prompt for the ambient temperature. At this point, we know that this is going to be a real number. So I'm declaring a real number called C1. And then here's my fake point called temp, and here's this generic construction. If we search for that, we can find all the places where we need to fix things. But the easiest way to do this in DMIS is just to have an FA being defined, and instead of the temperature being nominal, we use that variable C1 to set it. So now we have a nominal of 68, and our temperature is plus or minus 2 with respect to that. And so we're outputting this temperature tolerance here which is an interesting way to get a temperature into a coordinate tolerance. So if I search for that generic, the next case looks like this. This min high-level language intrinsic function is DMIS valid, but this dot hit number of hits thing dot x, that's pure PC DMIS, so that's not a valid DMIS thing. But it's clear what it's doing here is it's finding the minimum x. It's finding the index of the point with minimum x, and then it's grabbing the x, y, z, I, j, k off of that. In DMIS, that can be handled using a construction called extreme. In this case, because we're looking for minimum x, we're looking for the minimum extreme of a point in a feature actual, and we're dealing with the x direction in this particular case, as we know from this and also from the name of the variable. And that feature name goes in there. And there are several more of these in the program that would need to be similarly adjusted. The last one here is rather more interesting. It's using a circle because there's a diameter tolerance being attached to that circle that's going to look at the distance between the max and the min over all of these features. Now, to do this in DMIS, you would have to obtain the measured x coordinate off of tip 1 into a variable, the measured x coordinate of tip 2 into a variable, and then figure out the max over all of those and the min over all of those. And probably at that point, it'd be more likely to set up a point at the max and a point at the min and doing a distance between. But there's quite a bit of hand editing that would be necessary to get that done. But that's the current state of the loader. It's complete except for the details of display precision and things like that. And of course, as I mentioned, we really can't do anything with the basic scripts because that's expecting to be hooked into PC DMIS.